All right, we're looking at the Inquiry Lab surface area of rectangular prisms, which starts on page 759. How can you use nets to find surface area? Nets are an amazing way for us to understand what a 3D shape looks like in 2D form. All right. So it says if you want to know the amount of cereal that you can fit in the box, you would find the volume. But if you want to know how much cardboard is needed to make the box, you would find the surface area. So I'm going to go over the example that they have, giving you some dimensions, and then I'm also going to have like a little demonstration for you as well in a separate video. Alright, so it says one way to find the surface area is to use a net. Nets are two-dimensional patterns of three-dimensional figures. When you construct a net, you are decomposing the three-dimensional figure into separate shapes. So step one says use a cereal box in the shape of a rectangular prism to measure and record the length, width, and height. Now, I'm not expecting you to do that on your own, so I'm going to give you dimensions now so that we can plug those in ourselves. So we're going to say 12 inches by 9 inches by 3 inches. Okay, so the length is our 9 inches, our width is our 3 inches, and our height is the 9 inches. And then it's saying to use, using a marker, it wants you to label the top and the bottom, the front and the back, and the side of the faces of the box. So I'm just going to draw another picture over here. Okay, and so here's our cereal box. And so we have the top and bottom. Okay, then we have, let's see, our front, and then we have our back. And this is a see-through picture, so wow, we can see everything. We have our sides, side, and that covers everything. Oh, yep, we got our top, our bottom, our front, our back, our side, our side. And as you know, there are 6 sides to a rectangular prism. So we've covered all of our sides. Top and bottom are 2, front and back are 2, and side are the other 2. So we have 4 altogether. So it says using scissors, carefully cut along the 3 edges of the top face and then cut down each vertical edge. Really, it wants us to basically really literally dissect this box. So I'm going to take pieces at a time here. So when we're talking about the front, and I'm going to highlight things and then I'm going to delete them as we go so that we can look at it again. So this is our front, which is, in this case, our 12 by 9 inch. So our front is 12 inches by 9 inches, so that is 108 inches squared. And hopefully that you understand that the back is the identical side to the front. And so again, that's 12 inches, 9 inches, 108 inches squared. All right. Ooh, and I just realized I'm not going to be able to take that out. So I'm going to have to use a different color. Hope this doesn't get too crazy. All right, now our sides we have are this side and this side. And we know that our side, or our depth is 3 inches. And we know that going up this direction is 12, because if this is 12 here, then this is 12 here, then this is 12 here, then this is 12 here, okay? And then if this is 3, this is 3, this is 3, and this is 3, we've got 3 everywhere. So it's going to be a 3 by 12, which will be 36 inches squared, and our other side is identical, so another 36 inches squared. Now let's change colors again. My beautiful purple. Now we're going to talk about our top and our bottom. And as you see, we've got a 3 by 9 shape. So we'll have 3 by 9, 3 by 9, and so the area for each is 27 inches squared, 27 inches squared. And so if we're adding them all up, we have, let me get a little closer so I can do this, we have 108 plus 108 plus 36 plus 36 plus 27 plus 27. Alright, and when we add those all up, we end up getting 342 inches squared. And that is the surface area of the entire box of cereal that we have here. So that means that's how much cardboard is needed to make each box of cereal. 342 square inches of cardboard. So think about when you're recycling. That's how much cardboard you're recycling when you get rid of a box of cereal. Alright, so an orthogonal, okay, you know I don't know how to say anything, so that's okay. The ortho drawings, let's go with that, that sounds good. The ortho drawings consist of separate views of an object taken from different angles. You can make a net from ortho drawings. So find the dimensions of each. Oh, I love this, okay. So find the dimensions of each. So we're making a chart, and they're going to call this the ortho drawing. Great. So they're saying let's take each of the sides, and we know that we're going to be multiplying it times 2, right? Each one of these is going to be times 2. So our front, we have 1, 2, 3, 4 by 1, 2, 3. Our side, we have 1, 2, 3, 4, 5, 6 by 1, 2, 3. And then our top and bottom, we have 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Alright, so that was step 1. We're finding the dimensions for each of the sides of a rectangular prism. And then it's saying to use grid paper to draw the net from the ortho drawing. Trace and cut out your drawings and tape it in the space below. So you're going to need a piece of grid paper. So it's a good time to pause the video and get some grid paper. If you don't have grid paper, just try to make your own, I guess, okay? But you need to get some if you don't have any yet. Alright, trace and cut out your drawings, tape it to the space below. If you just want to have it separate, that's fine. You don't have to cut and paste and all that good stuff. So, let's see. I'm going to go ahead and put this together and you can see if it matches up with yours. So you can either experiment and try and do yours on your own right now, or you can wait and I'll show you what we're going to do. Alright, so in Imagination World, this looks like a beautiful drawing. You're welcome, you're welcome. So I've labeled everything. I started with my front, which was a 4x3 shape, and I went ahead and put that in the middle. That's where I always start. Right in the middle, front, and then I hope that I have enough room to go up to put my top in and my bottom in down. So my top is up on top, my bottom's down below. And then my sides are side and side. Now, the one trick is the back. The back is connected to the sides, but not the front, okay? You could have also, instead of having it here, you could have had it over here and did this, okay, and said this is the back, because it could also be connected to the top. And I don't know if you can visualize this, but it would wrap around. Okay, I don't know if you can visualize that, but it would wrap around. So either it's, you know, being bent over here using this one, or it's going to be from the bottom and bent that way. Okay, and my little lines, my little jagged lines are where you are folding the paper. Okay. Alright, step 3 says fold the net into a 3-dimensional figure and then draw the resulting figure in the space provided. So if you folded on these dotted lines, you would have basically, this is this, and here's our amazing 3D shape. Okay, well, let's go with it. Okay, so, you know, it's a narrow, longer narrow box is what we're really talking about. Maybe like a shoebox kind of shape. Okay, so the figure is a rectangular prism. And it has a surface area of, well, that really I'd have to go back here. The surface area is 12 inches squared and 18 inches squared and 24 inches squared. And then each of these is multiplied by 2 because I have 2 sides, a top and a bottom, and a front and a back. So I'm going to be doing times 2 for each one. And so I'm going to get 24 plus 36 plus 48. That's all my dimensions doubled. And then we'd add all of these together, and that's going to give us our surface area. And that would be 108 inches squared. So coming back over here, that's going to be 108 square units, or I guess I was going with inches, which I completely made up on my own. So I'm going to have to change those all to units because I just made up inches by myself. All right, I guess I was going for my original experiment. All right, so the investigate part, it says that you're going to use a net to determine the surface area of each prism. Draw the net of each prism on the grid provided. Again, let me tell you, the key here is to decide what you're going to start with, and I always start with the front. So if I'm looking at this box here, because it's a cube, this is my front. So my front is a 2 by 2 shape, because I know that if this side is 2, then this side is 2. Okay, so it's a 2 by 2 shape. So in the middle, I'm going to do my 2 by 2, and that's my front. Then I'm going to do, and how about I label it front with an F. Then I'm going to do my top, which is also a 2 by 2 shape. I know it's a 2 by 2 because it's 2 is here, so that means 2 is here. 2 is down here, that means 2 is down here. Let me change a color so you really see what I'm talking about. So if 2 is down here, then that means it's up here. And then if 2 is down here, it means it's up here, because these are squares. This is a rectangular prism, and this happens to be a square, which is a cube. So this one is our top. And of course, our bottom is the same because they're matching. They come in pairs. And so there's the bottom. Now we need to do our sides. So let me get a different color for the sides. So over here are the sides. And again, it's going to be 2 by 2. So I'm going to do 2 by 2, and here's side. 2 by 2, that's another side. Now the only thing I'm missing, if you notice, I only have 5 parts right now, and we should know that a rectangular prism has 6 sides, and I'm only showing 5 sides in my picture. I'm missing the back. So I need to add the back. Let's see what color I'm going to use. How about a green? And I'm going to attach that right here. It's also going to be 2 by 2. Sorry, the back right here is our 2 by 2 as well. All right, and so this will be BA for back. How's that? In a perfect world, I could write better. All right, so now it also wants us to determine the surface area. The way that I do this is by using that ortho drawing that they were talking about, which I'm going to call the chart from now on. And I'm going to say front, back, side, and then top, bottom. Okay? And so I know that this is a 2 by 2. This is a 2 by 2. This is a 2 by 2. So I know the area for my front and back will be 4 inches squared. That my area for my sides are 4 inches squared. And my area for my top and bottom are 4 inches squared. There's 2 of each of these, so I'm actually going to do 8 plus 8 plus 8, because it's 2 times 4, 2 times 4, 2 times 4, and add all those together. And my final answer is that, why do I always go to inches? Sorry, guys. Whoever caught on to that, good job. Millimeters, millimeters, millimeters. Okay, so we've got 24 millimeters squared. All right, so I made a mess of that. Let's try and make the next one neater. If you need a separate piece of paper to show this, then go for it. You'll definitely need graph paper to write this out, though. All right, so let's do the next one together, and then I'll have you work on 3 and 4 on your own, although this should be... Actually, you know what? Skip over 2 for just a moment, and hopefully I'll remember to go back to it. And let's go on to 3, since 3 and 4 both have a half on there, and I want you to see what to do about that half. All right, so let's go to number 3, and we're dealing with a rectangular prism that's a 2 by 4.5 by 1. All right, so drawing our net first, I'm going to start with my front. So my front is this right here, which is 2 by 4, and I try and get in the middle here. So 2 down, and it's going to be 4.5 across. So this should be interesting. I'm I'm going to enlarge this so I can get up closer to it. 1/2. Okay. So this is across 4.5. I hope you can see that. So that's my 2 by 4.5. Then my, and this is my front. Okay, and I really could just write out the whole word front, so why don't I not be lazy? Alright, front. There we go. Alright, next, I'm going to change colors, and if you'd like to do the same, then go for it. Next, I'm going to do my top. So my top is right here. So I know that my top is 4.5 inches, sorry, inches, why am I going there? 4.5 feet, because if this is 4.5 feet, then the top is also 4.5 feet, and that's the units I'm using. And then I know that this depth right here is the same as this, which is 1. So I'm going to go up 1, and I'm in the middle there, and across 4.5. And this is my top. Okay, my bottom is the same thing, so I'm going to go down 1 over 4 1/2, and this is going to be my bottom. Alright, now I need to do my sides. Let me change color, and my sides are right here. It's 1 by 2, and the reason I know that it's 2 is because this side right here is 2, so this side right here is 2. So I'm going to go from the side here out 2, which is tricky because I'm going to have to go a half, a full, and a half to make 2 whole. And then, oops, and I went too far out. Sorry, let me say this over again. This is already 2, and then I'm going to go out 1, which in this case, I'm only going out a half plus a half. I know that kind of looks crazy, but that makes it work. And over here, luckily, I can go out 1 full box, which I know I made that look a little bit crazy. Let me redo that. I don't know how much neatness counts whenever you're using your finger to do this, but, you know, we'll go with it. All right, give me a break, people. All right, so these are my sides. Those are my 2 sides. And then, if you notice, I've only got 5 parts, so I'm missing the back. I've got top, bottom, side, side. Now I need front and back. So back, we're going to go back to green, and we're going to do the back. And listen, I didn't leave enough room over here to do, 4.5 across kind of deal. So instead I'm going to do it from the bottom here. It's going to be 2 by 4.5. And this, oops, and this is the back. Now, I'm going to try and make this a little neater. I'm going to make my table. I'm going to blow this up a little bit. I'm going to make my table. And we've got our front, back, our sides, and our top, bottom. Okay? And so the dimensions for my front and back are 2 by 4.5. So I'm going to do 4.5. My dimensions for my sides are 2 by 1. And my dimensions for my top and my bottom are 4.5 times 1. So I figure out what this equals. This is going to be 9. 2 times 4.5 is 9. 2 times 1 is 2. And 4.5 times 1 is 4.5. And these are my inches squared, inches squared, inches squared. Now, to put them together to make my surface area, I actually need to take all of these and times them by 2. So I'm going to have 9 inches squared times, oh, why do I keep going to inches? I'm crazy. Okay, sorry, I just erased way too much. All right, so this is 9 feet squared. This is 2 feet squared, and this is 4.5 feet squared. All right, now, so I'm going to double each one. So 9 times 2 is 18, plus 2 times 2 is 4, plus 4.5 times 2 is 9. And then when I add all of these up, I get 31 feet squared is the area to my rectangular prism for number 3. I know this is a lot of work, but we're preparing because you're about to keep doing this for the next couple sections. So I'm sorry, it's not getting easier. We're just going to keep building and building and building. Trust me, you're going to be doing this again in 7th or 8th grade, along with in Geometry 1 and 2. It's going to keep coming back. All right, so you're going to do number 2 and 4, and when you come back, I'll show you the answers to each one. So pause the video now. Please pause the video and try and do this on your own. Don't just copy my work. I just gave you 2 examples. If you need to rewind and watch the examples again, please do, but try to do 2 and 4 on your own. I'm trusting you guys. Pause the video now. Alright, and here are the answers for number 2. Look through my picture and notice I had to extend the graph, which I can't believe they didn't give us a graph big enough to handle this, but I guess not. So check your graph and see if your measurements kind of go with mine, and in the end, when we set up our ortho chart, which I'm going to call it the chart, we see that it's going to be the front and back are each 6 inches squared, the sides are each 8 inches squared, and the top and bottom are 12 inches squared each. And so we multiply each of those by 2, and we end up adding those together and get 52 inches squared. Alright, now number 4. Alright guys, so number 4, as you can see here, ends up being 27 meters squared. So check your work, see if you came to the same conclusion as me, and compare your answers with mine. Notice that color coding is really very helpful in what I'm doing right now. But one of the key parts that you really need to be paying attention to is figuring out what the units are. For instance, you had to know what the height is here by looking at the height from over here and knowing that if this is 1.5, this is 1.5, this is 1.5, you had to know that they're all 1.5. Okay, all of the heights are 1.5, just like all of these lengths right here are 3, 3, 3, 3. Okay, and all the depths are 2, 2, 2, and 2. Alright, so it's important for you to see that. Alright, so the next one, number 5, says draw a net on the grid from the ortho drawing and then find the surface area of the prism. Alright, so go ahead and work on this. See if you can do this on your own. Go back and look at my example if you need to. And I know that this is a long video, but you really need to understand it. Alright, so check your answer and see what you think. I got 62 square units. With my ortho drawing over here, I went ahead and set up part of my chart where I have my finding the area of each of the sides. And then ultimately I take this and I multiply it times 2 each and then add them all together to get 62 units squared. When I drew my picture, I just took my front, which is also always my middle part, and I put it right over there, right in the middle as best I could in the center of what I was doing. And then I put my sides in next, and then my top and bottom, and then my back I was able to put over on this side. I didn't have room to put it here instead. Alright, so if that needs to slow down, watch it again. Sorry. Alright, so go ahead and do 6 through 9, and when you come back, we'll go over it. Pause the video now. Alright, so go ahead and check over your answers. Obviously, if you get the final answers correct, then you're agreeing with my numbers. So if you can just check this column first. If something's wrong, then you can see. Now, it's not necessarily that you had to know which one was the top, which one was the bottom, and all that. But what I did to start with number 6 is I went ahead and drew a picture and labeled it the 2 by 2 by 3, and then I just kind of looked over and figured out, what would the top be, what would the front be, what would the sides be, and so forth, and plugged those in. Then I realized when I put in my 2 times 2, 2 times 2, 2 times 3, 2 times 3, 2 times 3, 2 times 3, it was almost like I was doing the first times the middle, then I was doing the middle times the third, and then I was doing the third times the first. You see what I'm saying? And so, obviously with number 7 and 9, it just was always 3 times 3 times 3 times 3, or 6 times 6 times 6 times 6. But with 8, that little shortcut really saved me some time. Of course, you could draw the picture again. You could draw the picture for every single one of these. If it helps you, great. But for number 8, I did the first times middle, and then middle times last, and then last times first. And that's how I went through the process. And there are my answers. So number 10 says, compare the surface area for exercise 7 to the surface area of exercise 9. How does doubling each dimension affect the surface area? So we're looking at, what were the two? 7 and 9. All right, so 7 and 9. So what does doubling the surface area or the dimensions, what does that do? You went from 54 to 216. Is that doubling it? Is that tripling it? Is that quadrupling it? If I'm increasing by a multiple of 2, remember that beautiful thing? Oops, I guess that's not going to look good. If I'm increasing my area by a multiple of 2, notice how when I went for here, increasing by a multiple of 2, that this actually went by a multiple of 4. And there's that 2 squared thing again, okay, that we talked about in another one of the sections from last chapter. All right, so what do we notice? How does doubling each dimension affect the surface area? It does the 2 squared or 4. So it does it by a multiple of 4. All right, write a formula to find the surface area of a rectangular prism. Use your formula to find the surface area of the prism in activity 2. Interesting. So go ahead and look back at, especially the table, and see if you can come up with a formula. And that'll be something interesting that you'll be able to use further on. So check it out and see what you think. Go ahead and pause the video. All right, so remember in that table how I was saying, let me go back, how I was saying it was the first times the middle, and then the middle times the last, and then the last times the first. Well, if we were labeling these length, width, and height, like we would have for volume, or if we were labeling, you know, our dimensions here in a cube, that would be, you know, like length, width, and height. We would be doing length times width. So length times width and length times width. We would be doing it twice. And then we would be doing width times height twice. And then we would be doing height times length twice. So I came up with this, that the surface area for a rectangular prism would be 2 times the length times the width plus 2 times the width times the height plus 2 times the height times the length. Ta-da! Aren't you so excited to use that formula? It's better than having to keep drawing it, I would think. All right, so go ahead and skip over 12 since everybody's going to have a different answer for that. Will the surface area of a cube ever have the same numerical value as the volume of the cube? Interesting. That's a real thinker. You guys can go ahead and think about that, but I think this video is long enough. So how can you use nets to find the surface area? We'll go on to number 14. I mean, obviously, that was the whole idea behind this section. How can you use nets to find the surface area? Well, it just told us how to use the formula. So how can you use nets? Well, it's got the dimensions on it. Okay, if I've got this as my net, okay, then I'm going to be, well, I guess I would have to stretch these out. I would know my length and my width and be able to do my, you know, this dimension by this dimension by this dimension by this, you know, you'd have all the dimensions. So the net gives us each piece, and then we can just add all those surface areas together. So you can find the area of this section, 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 because there are 6 sections. And then add them all together, and you get the area of the entire thing. That's a beautiful drawing. You're welcome. You know, my art just keeps coming through in these videos. All right, guys. Well, that's the end of our Inquiry Lab surface area of rectangular prisms. I guarantee you that our next video won't be so long. I just had a lot to get through. Thanks so much, and I'll see you in school.